12-1, graphing system of inequalities. I believe this is page 73. And the date that we're using is for 3/21/2013. The system of linear inequalities is the ordered pairs that satisfy the open sentence or sentences of the system. Example number 1 is graph y is greater than or equal to x minus 4. We'll do that line in red. And y is less than 3 minus x. That line or that equality in blue. So I'm going to take this first inequality, take my color string, and write out what it is I know about it. I know that the greater than equal to symbol suggests a solid line. I know the slope is 1/1, and the b, the y-intercept, is -4. For the blue line, or inequality, I know the less than symbol suggests a dotted or dashed line, and the slope is -1/1, and the b equals a +3. So let's plot some points and get our inequality graph. M equals 1/1, and we start at -4. We're going up 1/1, and so on and so on. And it's going to be a solid line. Looks like that. And while I'm on this inequality, let's test the point 0, 0. So 0 is greater than or equal to 0 minus 4. Just plugging in the 0 and the x and the y coordinates. So I get 0 is greater than or equal to -4. Is 0 greater than or equal to -4? Yes, it is. And so I'm going to shade where the 0, 0 is. I'm going to color on this side to include 0, 0. Now I'm going to switch to blue, plotting the y-intercept first at b equals 3. Going down 1/1, down 1/1, and drawing my straight line that is dashed or dotted. Looks like that. And now I'm going to test the point 0, 0. 0 is less than 3 minus 0. Is 0 less than 3? Yes, it is. And so I'm going to shade where the 0, 0 is on that side from my blue line. And those two spots where they intersect, I'm going to call that solution set X. Those are all ordered pairs that satisfy the inequality. So let's try that again. If you can graph the lines yourself, that's good practice. I'm assuming, just by experience, that you're probably going to need some help with the shading tonight and tomorrow in class. So here we go. Red line is going to have a y-intercept of 0. It's going to have a slope of 3/1. So I don't want to test the point 0, 0 for this one because the line starts at 0. I'm going to pick a new test point. This line is also a solid line. That is a red line. my y-intercept and my slope? Well, I can put this into the y equals 4 by subtracting x from both sides. I get y is less than or equal to negative x minus 2. So my slope is negative 1 over 1. My p equals is a negative 2, so that's where I'm starting. Negative 2, and then going down 1 over 1 for each point. I'm going to plot a solid line. It's blue. That looks like that. And now let's talk about the shading. Let's start with the red. And I can't use 0, 0, so let's pick a new point. How about negative 1, positive 1? Negative 1, positive 1. So the y-coordinate is 1, greater than or equal to 3 times the x, negative 1. Is 1 greater than or equal to negative 3? Yes, it is. So I am shading towards that point from the red line. And now the blue. I can use a different point. I can use 0, 0 again if I would like. Or I can stick with the negative 1, 1. So 0 for the y-coordinate is less than or equal to, well, I can't have a negative 0, 0 minus 2. 0 is less than or equal to negative 2. Is 0 less than or equal to negative 2? I don't think it is. 0 is bigger than negative 2. So this is no. And because I use the point 0, 0, I'm not going to shade that direction. So the blue line is shading away from 0, 0. Away from 0, 0. Where does the red and the blue overlap? That is my solution set. That is in this space here. So all of the values in this space here are my solution set, my S. Sometimes they call the solution set an A or an R. We're just going to use S to be useful. So moving right along to examples 3 and 4, starting with my red line, x is greater than 0. This is a dotted or a dashed line. It is a line that crosses the x-axis at 0. Cross the x-axis. So how do I get across the x-axis? A dashed dotted line. I am going straight down like that, crossing my x-axis right there at 0. So I'm not going to use the test point 0, 0. I'm going to pick something else. Let's pick 5, 0 as our test point. You can test any point you possibly want. So the x-coordinate, 5 is greater than 0. There's no y to substitute. 5 greater than 0? Yes, it is. So I'm going to shade over towards that point 5, 0. Switching to the blue, subtracting x from both sides to get y is greater than or equal to negative x plus 5. Have a slope of negative 1 over 1 of p equals of 5. I'm going to plot that. And am I drawing a solid or a dotted line? I'm drawing a solid line. Like that. Now I need to do a test point. I'm going to test the point 0, 0 this time. I choose 0, 0 most of the time just because it's an easy, they're easy numbers to work with. So 0 is greater than or equal to negative 0, or just 0, plus 5. So is 0 greater than or equal to 5? No. So I'm going to shade away with that blue line, away from 0, 0. And I'm going to mark my solution set where the red and the blue overlap. They overlap right there. For example number 4, why don't you try this one on your own? Pause, do it on your own, and see if you get the same solution set in the end. But make sure you do it in pencil so you can use the range. We're going to subtract x from both sides. I get negative x plus 9. Bring down the 2y and the greater than or equal to symbol. I am dividing everything by 2. I am not flipping my sign because I did not divide by a negative. I get negative 1/2 x plus 4.5, or 4.5. So let's plot this. At 4.5, in between 4 and 5, and I'm going down 1 over 2. So all of my points end up being between the coordinate line. And this is a solid line in red. That looks like that. Now switch to blue. And I am going to add x to both sides. So I get y is less than or equal to x plus 0, or just x. Now this is a line going through the origin with a positive 1 over 1 slope. This is another solid line in blue. That looks like that. And now let's talk about the shape. So if I tested the point 0, 0 for the red, I can use the original if I want. 2 times 0 plus 0 is greater than or equal to 9. Well, 2 times 0 is 0. 0 plus 0 is 0. Is 0 greater than or equal to 9? No, it is not. So from the red line, you are not coloring or shading on the side where 0, 0 is. Going away from it. And now to switch to blue, I think it's not really a good idea to test 0, 0 because the line is going through the origin at 0, 0. Let's test the point 5, 0. And so the y is 0 less than or equal to x, which is 5. Is 0 less than or equal to 5? Yes, it is. And so I am going to shape from the blue line towards that point 5, 0. Again, the spot or the space that they overlap goes right along the blue line, right along the red line, and it's over here, all this area in here. We call that solution set X. I'm just marking it to make it a little bit more bold or easier to stand out and see, but you could just normally put an S there to mark the solution set. We will do a lot more practice around in class. Have your notes ready to go so that you can refer back to them.